Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on June 30th, 2025. Published just yesterday, this paper introduces a novel attention mechanism that achieves a nearly 3 times speedup for training video models, without sacrificing quality. The paper is titled VMoBA, Mixture of Block Attention for Video Diffusion Models, and the efficiency gains here are pretty significant. The authors adapt a sparse attention method, originally for language, to better handle the unique structure of video data, tackling a major computational bottleneck. Alright, the first figure really visualizes these claims. On the left, we see generated video frames of a sheep. The new VMoBA method not only trained fastest at just 187 GPU hours, but also produced the highest quality video. The charts on the right then quantify this. One shows that as videos get longer, VMoBA's generation time, or latency, stays much lower than the standard method. The other chart plots quality against computational cost, measured in giga floating point operations per second, basically how many calculations are needed. It clearly shows VMoBA achieving top-tier quality with a much lower computational cost. So how does VMoBA achieve these impressive gains? This next diagram breaks down the 3-step pipeline. First, it partitions the video data. Instead of just flattening it, the model intelligently cuts the data into blocks, sometimes along the time axis, sometimes across the image space, or a mix of both. This approach better respects the video's structure. Then, it ranks these blocks by importance and selects only the most relevant ones to pay attention to. Finally, the model calculates what's called sparse attention, focusing its computational power only on these few, selected blocks, which is the key to its efficiency. This table then details the training-based results, and it really puts numbers to those claims. It compares VMoBA against several methods, including standard full attention and the original MoBA. Across various quality metrics, you can see VMoBA consistently scores on par with, or even better than, the much slower full attention method. But the real story is in the efficiency columns. For a long video, VMoBA cuts training time from 262 GPU hours down to just 182, a nearly 1.5 times speedup, while requiring almost 3 times fewer calculations. Building on those results, the authors then perform what are called ablation studies. This is where they test each component of their new method individually to see exactly what makes it tick. The 4 small charts here show these tests. They confirm that the best design choices are their unique 1-2-3D block partitioning method and their threshold plus global selection strategy. These specific choices, highlighted in the table, provide the best balance of video quality and speed, justifying the final VMoBA architecture that achieves those impressive results. So to wrap things up, those ablation studies really confirm why VMoBA works so well. The paper focuses on video diffusion models, which are AIs that create video by starting with random noise and slowly refining it into a coherent movie. The key innovation is a tailored sparse attention mechanism. Now, a sparse attention mechanism is a technique that makes models more efficient by having them focus on only the most important pieces of data, instead of everything at once. By designing this specifically for video, the authors achieve a nearly 3 times speedup in training while maintaining quality. It's a powerful result. That's all for this week's AI Research Roundup. Thanks for tuning in.